want to welcome you to the lecture for section 12.2. This is MGF 1106 Liberal Arts Math, and my name is Jorge. So the objectives for this lesson is that we're going to understand the fundamental counting principle. We're going to go ahead and use slot diagrams to organize information in counting problems, and we're going to know how to solve counting problems with special conditions. So now, the fundamental counting principle. If we want to perform a series of tasks, and the first task can be done in A ways, and the second can be done in B ways, and the third in C ways, then all of the tasks can be done in A times B times C ways. So what we do is we multiply the choices for the first slot, the choices for the second slot, and then the choices for the third slot, and that gives us all the possible ways that we can organize these three tasks. So here's the example from section 12.1. So a group is planning a fundraising campaign. Now they're going to use two different endangered species, one for a TV commercial and one for online. Now the candidates are the cheetah, the otter, the ferret, and the Bengal tiger. So in how many ways can we choose the two animals for the campaign? So the first thing is we choose an animal for the TV campaign, and that can be done in 4 different ways because we have 4 animals. Then we choose a different animal for the online ads, and we'll only have 3 animals left. So the total number of ways to choose the animals is going to be 4 for the first one and 3 for the second one. 4 times 3 is 12 different ways we can choose the animals. So here's another example. How many ways can 4 coins be flipped? Well, flipping the first coin can be done in 2 ways. Flipping the second, third, and fourth coins can also each be done in one of 2 ways, either heads or tails. So the 4 coins can be flipped in 16 different ways. The next example, how many ways can 3 dice, red, green, and blue, be rolled? So now, rolling the red die can be done in 6 ways. Rolling the green die and blue dice can also be done in one of 6 ways. So the 3 dice can be rolled in 216 ways, which will give you an idea for that pop quiz question. So here's another example. A summer intern wants to vary his outfit by wearing different combinations of coats, pants, shirts, and ties. If he has 3 sports coats, 5 pairs of pants, 7 shirts, and 4 ties, how many different ways can he select an outfit consisting of a coat, pants, shirt, and a tie? So the options for the intern are the following, right? So he has 3 coats, 5 pants, 7 shirts, and 4 ties. So he has 420 possible outfits because he has 3 coats that he can use, 5 pants, 7 shirts, and 4 ties, and any combination of those will give him 420 different outfits. Now we're going to talk about slot diagrams. So a technique that's useful for solving problems involving various tasks is to draw a series of blank spaces to keep track of the number of ways that you can do each task. And this is what we call a slot diagram. So here, if you have 5 tasks, then number of ways you can do the first one, number of ways you can do the second one, all the way until the number of ways you can do the 5th task. So here's an example. A security keypad uses 5 digits, 0 to 9, in specific order. How many different keypad patterns are possible if any digit can be used in any precision and repetition is allowed? So since repetition is allowed, we have 10 digits for the first one, 10 for the second, 10 for the third, 10 for the fourth, and 10 for the fifth, which gives us 100,000 possibilities. Now using a slot diagram, this is what it would look like. Now, in the example before, we can use any digits. Now, but suppose that you can't use 0, right? So 0 cannot be the first digit. But otherwise, any digit can be used in any position, and repetition is still allowed. In that case, since we only have 9 choices for the first one, it's going to be 9 times 10 times 10 times 10 times 10, which is 90,000 possibilities. And then, excuse me, using the slot diagram, here we do the same thing. So we can't use 0, so we only have 9 choices. But then the rest of them, we can use any of them, and that gives us the 90,000 choices. Now, in the previous example, suppose that any digit can be used in any precision, but repetition is not allowed. So therefore, we can't have 1, 1, 1, 1, 1, right? And so how many possibilities do we have then? So here the slot diagram indicates that we can have 30,240 possibilities. So 10 for the first one, 9 for the second one, 8 for the next one, then 7, and then 6. Because every time a digit is chosen, it's taken out excuse me, out of the group of digits that's going to be used for the next possible digit. So here's a special condition. College class has 10 students. Louise must sit in the front row next to her tutor. If there are 6 chairs in the first row of the classroom, how many different ways can students be assigned to sit in the first row? So you got to consider the following tasks. The first thing is assign 2 seats to Louise and her tutor. Then you're going to arrange Louise and the tutor in these 2 seats, and then you're going to assign the remaining seats. So the first one, there are 5 ways to assign 2 seats to Louise and her tutor. So here we go. Now, the next task. There are 2 ways that Louise and his tutor can sit in their seats. Louise sits either on the right or on the left. And the last one, the remaining 4 seats will be filled by 4 of the 8 students left. Thus, we have 8 students for the first remaining seat, 7 for the second, and so on and so on. So we have 16,800 possibilities. So again, the first one is 5 ways to choose seats for Louise and the tutor. And then there are 2 ways to sit Louise, either to the left or to the right. And then after that, we start counting down the students. So those are the total number of possibilities. And that's the end of section 12.2. Thank you.